This is a lecture on solutions of linear inequalities. Okay, first thing, let's talk about how the graph will look like. Okay, there are altogether 5 scenarios. For example, what does it mean, or how do you draw? What's x greater than a? Okay, so all you need to do is draw me a number line, mark down a on the number line, a representing a number, and observe the inequality. It doesn't have an equal on it, so it's going to be an open circle, and I need you to point towards the right, okay? Because we are talking about numbers that are bigger than bigger than the number a, so pointing to the right is telling me that all numbers to the right of a works. Okay, now what is the difference between the first case and the second case? You notice the difference in the sign. Now there is an equal under the inequality. The number is still a in question, except to distinguish the difference, the circle is now darkened and filled. Okay, so it's filled circle and is still pointing towards the right. So the difference between this open circle and the closed circle is basically you're saying that in the first scenario, a is not included in your set, whereas in the second scenario, a is included in the set. Okay, so starting from a, it goes all the way to the right side. All the numbers to the right of a is a solution to the set. Okay, now what other scenarios are there? Okay, what if the sign points this way? So we're talking about numbers that are less than a. Okay, so less than a, so we're going to draw a number line. The question is a. There is no equal, so it's open circle and it points to the left. So we're talking about numbers that is less than the number a. So before I continue, what I need you to notice is the arrows seem to match the inequality. Okay, so some students are using the inequality sign to help them remember where the arrow is pointing, and that's okay, provided the variable is on the left. Okay, which is why we always keep the variables to be on the left side. Alright, let's continue. What happens if there's an equal under the inequality sign? Then the difference is that it's going to be the a, but it's going to be a filled circle, and the arrow points to the left. Now you notice that when I draw the graph, my number line is above, my arrow is actually above the number line. This is quite different from what you see in the book, because the R arrow is actually on the number line itself. I think it's easier for us to draw it above because we write in one ink or one pencil. Okay, unlike the book where they actually use different colors to represent the set. So they can afford to put it on the number line itself, but for us it would be clearer if we can draw the solution set above the number line, okay, like what I'm showing you right now. Now the last scenario is what happens if we want to say that x is a number. It represents a set of numbers that is between two numbers, okay, between a and b, and let's say there's an equal sign where b is. Okay, so this is the way you would draw the inequality sign to represent numbers that's between. Okay, so observe the inequalities are pointing in the same direction. So this time there are two numbers involved, a and b, but between x and a there is no equal sign, so I'm going to have an open circle on a, and between x and b there is an equal sign, so it's going to be a closed circle. Okay, so between a and x there is no equal, so it's an open circle, and between x and b it's with an equal sign, so it's a closed circle, and join these two circles with a line, and that's representing in between. Okay, so now that you know how the graph looks like, the next thing you need to know is in solving an inequality. So let me write this down. In solving an inequality, there is something you must remember. Okay, so you must remember to reverse the sign when multiplying or dividing by a negative number. So make sure you take note, it's only when you multiply or divide and only if it's a negative number. Okay, so when you multiply or divide by a positive number, there is no change in sign. So you do not reverse the sign. So let's make sure you totally understand. Let's do some examples. Let's try the first one that says, can you solve 3x less than 4 parentheses x minus 1 plus 1. So just like what you would do in solving an equation, the first step is to remove parentheses. So let's go ahead and remove the parentheses. And so next line reads 3x is less than 4x minus 4 plus 1. Observe there is no change in the sign. Okay, so step 2 says combine like terms. So let's go ahead and combine like terms. Minus 4 and plus 1, they can be combined. So 3x is less than 4x. Minus 4 plus 1 is negative 3. Again, there is no change in sign. Alright, so after step 2, step 3 says I'm supposed to apply addition property. And that allows me to collect terms to the same side. So the 3x and the 4x, they are separated. I need the variables on the left. So I'm going to bring the 4x over. So it's going to read 3x minus 4x is less than negative 3. Still, there is no change in signs. Okay, so let's combine them. 3x minus 4x, if you combine this, it becomes negative x, or rather negative 1x, and is less than negative 3. Okay, so still there's no change in sign. Now at this point, so I'm reminding you again, if there is a negative in front of the x, it really means negative 1 times x. Okay, so to get rid of the negative, you have to divide both sides by negative 1. Now this is the part you need to remember. When you multiply or divide by a negative quantity, the signs have to reverse. So if you observe the sign right now, this sign will now be reversed. Okay, at the same time when you're doing the division, the signs change. So the next line is going to read x greater than 3. And that's your solution. Okay, so let's talk about how the graph will look like. So let's draw the graph. All I have to do is draw me a number line. The number in question is 3. Okay, and between the variable and 3, notice there is no equal on the inequality. So I'm going to use an open circle. And I'm going to point towards the right side to mean numbers that are bigger than 3. Okay, so let's look at another example. Let's call this example 2. Okay, for example, I would say, can you solve and graph? Okay, solve and graph. Let's try a problem that has fractions in it. So let's try 5 over 3x minus 2 is greater than 17 over 7x plus 4. So just like how we do for equations, observe that this problem has fractions. Okay, so we're going to apply step 0, where it says, can you clear the fractions? So there are 4 terms, 1, 2, 3, 4. So I'm going to multiply everyone by the LCD. So look at the denominators. The LCD in this case is 21, because it's 7 times 3. I'm going to multiply everybody by 21. Now in the first term, you notice 3 goes into 21 7 times. 7 times 5x gives me 35x. Minus. There is nothing to cancel on the next one, so I'm going to multiply 21 and 2. That makes it 42. Greater than. 7 goes into 21 3 times. And I'm going to multiply 3 times 17, which makes it 51x. Okay, plus the last one, there is nothing to cancel, so I'm going to multiply 21 and 4, which makes it 84. Okay, so there is no parentheses to remove, so I'm jumping to step 2, which says combine like terms. There is no like terms on the same side, so I'm skipping to step 3. And step 3 is talking about adding property, okay, addition property. So I need the variables to be on the left, and the numbers on the right. So 35x gets to stay. The 51x I'm bringing over, so it becomes minus 51x is greater than. 84 stays, and the 42 comes over. So minus 42 becomes positive 42 and plus 84. Okay, so I'm going to combine the variables now that they're on the same side. 35 minus 51 makes it negative 16x, greater than 42 and 84 makes it 126. Okay, so this is the part you have to be careful. The next thing I'm going to do is I'm going to divide by negative 16. Watch out, you're dividing by a negative number, so make sure you reverse the sign at the same time. Okay, anytime you multiply or divide by a negative quantity, reverse sign. So watch out for that. Let me remind you, reverse sign. Okay, so what you have is x on the left. The sign is being reversed, so it's pointing this way now. And now I have a fraction which I should reduce, so that makes it 8, and that's a 63, so my answer is negative 63 over 8. And that's my answer. Okay, so since the question says can you solve and graph, I'm not done, so I'm going to draw my graph now. Number line, the only number I need to see is negative 63 over 8. Between the variable and the number there is no equal, so I'm going to use a open circle instead of a closed one, and I'm going to point towards the left side, which means that it's numbers that's less than negative 63 over 8. Okay, let's try a third example. This time something a little different. Can you solve and graph? Okay, and let's try something like this. 4x minus 3 is greater than 7, but less than or equal to 13. So you notice that your objective is the same. You're trying to get x alone, and notice that the only portion that carries the variable is the middle piece. Okay, so let's focus on the middle piece. My objective is to isolate the variable. So the first thing I want to do is to get rid of the 3, because I'm applying addition property. The only difference now is there is not both sides, but more 3 sides. Okay, so I have to add 3 to the middle, I have to add 3 to the right, I have to add 3 to the left. So long as you're fair, okay, what you do to one side, just do to every other side. And so what you have in the middle, the 3 is going to cancel, leaving you with 4x. the inequalities, there is no change because I'm not dividing or multiplying by negative numbers. And the number on the left is a 10, and the number on the right is a 16. So I'm still focusing on the middle section because I want to isolate the variable. And I know now that I need to divide by 4. But 4 being a positive number, there is no change in the sign. So observe, the signs stay the same. So x is in the middle now. 16 over 4 is 4. And 10 over 4 I can reduce to become 5 over 2. Okay, no change in sign. So as far as solution is concerned, that's the end. But since the question asked you to graph as well, so let's draw a number line. Except this time there are two numbers. 5 over 2 is one of them, 4 is the other one. Between the variable and 5 over 2, that inequality sign right there doesn't have an equal, so I'm going to have an open circle. Between the variable and 4, there is an equal right there, so I'm going to use a closed circle. And I need to join the two circles to mean that is in between.